All right, so I think I'm recording. Let's take a look at these two problems. They're both compound inequalities, but you can see on the left that there's three sections to it. This will be a compound inequality that we use the word and over here in number 14 will be a compound inequality that we use the word or. And it's always that word or will always be written where the word and may or may not be. All right, in number 13, I also notice that I only have the variable in the middle portion, that I don't have the variable in all three sections. So sometimes I think the ones that just have the variable in the middle are easier to solve because I don't have to split it into two inequalities. I can just um, work with it just as it's written and get the x in the middle by itself. So I'm going to subtract 5 from all three sections. So negative 11 minus 5 is a negative 16. And when I subtract 5 in the middle part, I'm just left with the negative 8x. And that's less than or equal to, and when I subtract 5 on the far right side, 69 minus 5 is 64. So if I divide all three terms here by negative 8, I'm going to have to change the directions of these inequalities. So negative 16 divided by negative 8 is positive 2. Negative 8 divided by negative 8 is positive 1. And positive 64 divided by negative 8 is negative 8. All right, so now I've got the x by itself. I like to have the arrows always pointing to the left, and notice that they're always pointing to the smaller value. So on the number line, this is telling me that my endpoints are negative 8 and positive 2. And see, if I write it with the inequalities always pointing to the left, then that left endpoint, it just matches up nicely with my graph. Now, I have to determine whether I want to shade these endpoints or keep them hollow. Since this contains equality, since it's underlined there, it's less than or equal to, and I shade in my negative 8, that endpoint. On the other endpoint, however, since it's a strict inequality, we don't see that it's underlined. I'm going to leave that hollow. And x is negative 8 is less than or equal to x, which is less than 2. It makes all the values that are between there is the points of interest. Pick any number that's in this shaded region, including that negative 8, and substitute it into the original inequality, and this will be a true statement. Pick some number outside of this shaded region, and it will be a false statement. To write this in interval using interval notation, we always have the smaller number, comma, the larger number. On the left here, the smaller number is included in my solution set, so I need a bracket, and positive 2, the other endpoint, is excluded, so I need a parenthesis. So this is my solution set for number 13. So let's take a look at this next one. Now it's written with a compound inequality with the word or. So I'm going to solve these two inequalities separately. I have 8x plus 9 greater than or equal to 89. Or I have 7x minus 4 being strictly less than negative 25. So on the left here, let's subtract 9 from both sides of this inequality, and I have 8x is greater than or equal to 80. Let's divide both sides by a positive 8, and I have that x is greater than or equal to 10. Now, over here on the left, let's get x by itself here. Let's add 4 to each side, and I have 7x is strictly less than negative 25 plus 4 is a negative 21. And let's divide both sides by a positive 7. And negative 21 divided by positive 7 is a negative 3. All right, so on my number line, my endpoints, my boundary points or critical points, endpoints, the points of interest, whatever you want to title them, is -3 here, and somewhere to the right of -3 on this number line is 10. So I want values that are strictly less than -3. I don't shade in that circle, and values to the left, I shade in values that are smaller, strictly smaller than -3. Now, greater than or equal to 10, this time I shade in the solid point because I want to include 10 in my solution set, and values of x that are greater than 10 are going to be to the right of 10. So here's greater than or equal to. So to write this using interval notation, the left arrow is shaded. That represents negative infinity. You'll never have a bracket around an infinity. Then up to -3, but excluding the endpoint. The mathematical symbol for the word or is a union, and it looks like a big U. And the union is that that x belongs to this set, or it belongs to the other set. So the other set includes the endpoint 10, and the right arrow is shaded, so that's going out to positive infinity. So here's my solution set for this compound inequality at number 14, and I had to have that U for union. So I hope that helps. Ask any questions if you have them. Talk to you later. Bye.